So, hello. Here we are in Global AI Zurich. Good morning, good evening, guten Abend, everybody. And at least we are having an interesting event that we organized. So I know it's been a while since we launched this user group. So here we are to unleash the power of agentic AI with StepWise, which is interestingly a workflow engine, but that I will let our guest today to introduce that. Today we have Xiaoyun Zhang. He's a senior software engineer working for Microsoft. He, as you can see on the images, he likes cats. He has one cat, not with him at the moment. And what can I say? I've interacted with him. He's an engineer working on the .NET team, mostly focused on AI for ML.NET and also on the Microsoft AutoGen team. And also, I know you don't like to hear that, but some of your colleagues told me that you're a fantastic developer and you have collaborated so much in the AutoGen. He's one of the persons that is behind what a lot of us are using today, which is the group chat in there. But without further ado, I give you the stage. Xiaoyun.
Okay, thanks, Jose. So let me bring the slides in.
You tell me when you're ready.
Yeah, I think it's now I have the PowerPoint. So Jose, can you see my screen? Can you see the? Let me know. Can you let me know when you can see the slide?
Yes, everything is visible, is perfectly well. We are live on LinkedIn, YouTube, and X as well. So go ahead.
Wonderful. So let's start it. So hi everyone, I'm Xiaoyun Zhang, and really glad to have this opportunity to introduce the StepWise to you, and also a big thank you to Jose who gave me this opportunity. And as Jose already introduced, I'm a software engineer in Microsoft. I've been mainly focused on the machine learning and .NET and the AI for .NET, and also I'm also working on AutoGen and AutoGen.NET, which becomes a very popular project in large model area. And in this session, we are going to talk about StepWise. StepWise is a .NET framework. It's a .NET open source framework on GitHub, where you can find the repo from this link. There's also an online demo for you to try out from the online gallery demo. And if you don't want to visit the online gallery, we also provide an offline gallery version to try out the examples in StepWise through the .NET CLI. And here's today's agenda. The session will come with two parts. In the first part, I will do a brief introduction about StepWise, including its concept, the architecture, and how to leverage it in your project, etc. And in the second hands-on part, I will show you how to use StepWise to build two agentic workflow. The first is weather chat, which we will build a weather chatbot that can provide weather information. And the second is chain of thought workflow, which we make the power of the chain of thought skill to improve the large language model response, large language model ability. And finally is the Q&A session. So let's proceed to the first part. So what is StepWise? StepWise is a .NET framework for you to code, visualize, and execute event-driven workflow. So here, it comes with three components, and they are distributed in three NuGet packages. The first and the most fundamental one is a StepWise.core, which provides the API for you to create and define the StepWise workflow, and also run the workflow using StepWise engine. And the second part is Web UI, which is a static front-end web app built on top of the popular front-end technologies like Next.js and Tailwind CSS. The purpose of the Web UI is to allow you to visualize and run the workflow that you define in your application in the browser. And the third part is the web API, which serves as an intermediate RESTful API to run a set of the RESTful API that will be consumed by the web UI to make use of the StepWise engine from the core library to run your workflow. And let's move to the next. And the StepWise come with 3 key features. The first feature is StepWise is a code-first workflow framework where you define the workflow using C# language and leverage the power of C# to create a workflow in a more structured and type-safe way. And in the StepWise, every workflow is modeled as a C# class, and every step in that workflow is modeled as a method in that class.
Xiaoyun, quick question. What made you make StepWise code first? Because everybody out there is doing or trying to do workflow engines with graphic GUI first. So I find this very, very interesting. So I'm really curious on what triggered this decision.
That's a great question. So I feel like there are 2 answers for that. The first is that by using the code first approach, I feel like it will be more comfortable for the developers to develop a workflow, because they will be able to reduce the working process for the coding. Like, you can have the unit test for the workflow that you define. You can also have the CI/CD pipeline as well. And the second reason is that using the code first approach, you can have the single source of truth for the workflow that you are working with. So you don't need to install the separate platform or separate software in order to run the workflow. The code will be the only file, will be the only artifact that you need to work with when create a workflow, and that will be much easier to distribute and to pack and distribute it to the users. So that's why I choose to start with the code first approach at first.
Nice, thank you.
And once after you finish coding, do the coding part, then you can either run the workflow in the browser using web UI, or you can also run it programmably using the StepWise Engine API. And the second interesting thing with StepWise is that it's event-driven. It's an event-driven workflow. It's corresponding to the reactive programming model, where you define the workflow by declaring the steps on processing data. So the difference between the event-driven workflow and the process-driven workflow is that in the event-driven workflow, you don't care about how the steps are being invoked at all. So you leave that part to the workflow engine. While in the process-based workflow, you define both the data processing steps and also the control flow on how you want to invoke those steps as well. The event-driven workflow brings 2 benefits in StepWise. The first benefit is that this event-driven workflow makes the parallel execution much easier comparing to the process-based workflow, because you can easily infer the dependencies among the steps. You can figure out what steps can be run in parallel and what cannot, by modeling the entire event-driven workflow as a direct acyclic graph. And the second benefit that bring by this feature is the event-driven workflow will be more AI-friendly, because every steps in that workflow is data processing steps. There's no control flow involved in the definition, which makes it a very clean model. And each step in that workflow can be easily mapping to a tool called definition, which is already familiarized by the mainstream large language model. So that brings to the third key feature, the AI-powered workflow. So in StepWise, you can use Gino, which is a built-in AI assistant, to run and analyze workflow for you. Gino can understand the workflow you defined and execute the corresponding step based on the question that you ask. It can also provide some insights on the result of the workflow. So we will show you some example about Gino in the latter part. So, and how to leverage StepWise in your project. It's fairly straightforward because the entire framework is available as a NuGet package. So you first add the StepWise package to a project. We have a 1-in-all StepWise NuGet package that take dependencies on all the necessary components. So you can install those components in one step. And after you install the StepWise package to your project, which can be either a console app or ASP.NET or even a WinForm app, you then write the workflow in your application, just like you write the other code. And after you finish the coding part, you can then either visualize and run the workflow in the StepWise web UI with some configuration to set up the web service, or alternatively, you can also run the workflow using the StepWise engine programmably. So let's talk about how to define a workflow in StepWise. To better explain how, let's consider a prepared example here, which consists by some steps like boil water and cook vegetables, etc. And you can probably notice that in the prepared dinner workflow, some steps have dependencies on the other steps, while some doesn't. For example, you probably need to wait the water get boiled before you proceed to cook vegetables, but you don't have to do that when cutting vegetables. You don't need to wait to boil the water before you go to cut the vegetables. That produce the following workflow, which take the dependency into consideration in the right side of the screen. And in each of the steps, we will, in order to mimic the running process, we'll simply print out the step name and the time it takes to run that step. For example, when we run the cut vegetables, we will just skip a few seconds and return and print out the vegetable get cut in 3 seconds, etc. like that. And we want to also record the time to when we start running this workflow and print out the total consumption time after all the step has been finished. And so let's first define the boil water step. In StepWise, each workflow is defined as a class, and each steps in that workflow is defined as a method in that class. So you can imagine that when it comes to the C# program, this entire workflow will be presented as a proprietary class, and each of the steps will be a public method there. So when defining the boil water, let's start with the boil water. You can see that it's just a async function which will return a string. And because this step doesn't have any input parameter, so as the input parameter list to be empty for the boil water. And in order to make the function as a step, you need to put a step attribution on top of that. This tells the StepWise engine, hey, this method is a step in the workflow. So take a look at the input and output and this dependency list, and take a look at for its input and output, and take it into consideration when you construct the dependency graph for all the other steps in this class. And another thing to notice here is that the step is async function. So essentially, we want to use the async await pattern to make sure the steps are non-blocking, because the StepWise engine will try to run the steps in parallel as much as possible. And inside this function, we just sleep 2 seconds and return a description message. And after that, let's go to define the other steps. So here, let's use the cooked vegetables as the example here. Unlike boiled water, cooked vegetables will have dependencies on the other steps. So this is being marked by the depends on attribution with the name of the step. So this tells StepWise engine that those steps will depend on the other step, and use that information to construct the dependency graph. And in the cooked vegetables, we also this step will also take the input as a result from the other steps. So this is done by using the from step method. So the from step will include a name which will indicates which steps the result of which step it should be used as the value to fill in the input. So here the from step cut vegetables means that use the return result from the cut vegetables to fill in the value of the vegetables when you invoke the cooked vegetables step. So you can imagine that the vegetables will be some value like vegetable get cut in 3 seconds, and the water will be the value of something like water get boiled within 2 seconds. And inside this function, we just sleep 4 seconds and return a description of message. There's another thing to notice is that the depends on and from steps is that one difference between the depends on and the from step is that depends on will change the dependency graph, while from steps will not. So from step essentially just tell the StepWise engine how to fill the value when you invoke a function, but depends on will tell the StepWise engine on the dependency relationships among the steps. So using the similar approach, we can define all the rest of the steps in this workflow. And let's have a quick look at how it looks like. So this is the entire class, a property in the class. You probably noticed that we also have a start step here, which records the time when it gets invoked. And in the serve dinner step, which is the final step, we also take another record of the current time, and we use that approach to figure out the entire time spent on this perfect dinner workflow.
Chayun, I really like it. It looks really simple, and I also really like that you have a predefined start. Is it possible to have? But first, one thing which I infer from all that you show is that this is a graph. You are building a graph with all the steps in a workflow, right? So it's basically we are using graph theory. So we are basically map a workflow made of steps as a graph, right?
Yes.
And the next question is, do we have the possibility to have different entry points, or it's always one single entry point?
You can have different entry points. So I can show that in the web UI, but you can invoke the individual steps. So for example, if you just want to cook vegetables, you probably the running order will be the cut vegetables, boil water, and cook vegetables. But if you just want to invoke the cut vegetables, that will be the entry point will be the cut vegetables, and the boil water will not get invoked. So the StepWise engine will try to figure out the subgraph when you set the target of the step to complete, and we'll use that to figure out we'll use that to only run the necessary step to that required to reach that target step.
That's
So,
super cool. That looks really, really useful. One more thing, and that's the last one question I have. Do you enable composability here? So do you have one step that can wrap an entire workflow?
that's not available right now. So in every step is just the individual step. Or maybe can you illustrate a little more about what do you mean by having one step to wrap the entire workflow?
Yeah, I could have prepare another workflow, like prepare dinner for 5, right? That triggers different instances of the prepare dinner, right, with some variations.
Oh, you mean the invokes other workflow from a step?
Yes, exactly.
Oh, that's not that's currently not available now, but that's
Okay,
like a very interesting idea.
thanks.
Thanks. So let's proceed. And now we define the prepared dinner workflow. So the next step is to run the workflow. So there are 2 options for you to run the workflow in StepWise. The first approach is using the web UI, and the second option is to run it programmably in the same place with in the C#. So that the programmable way might be useful when you want to integrate StepWise in the existing application, or you just want to leverage the StepWise workflow with other framework, like all the semantic kernel. But we will go with the web UI approach first. So what is web UI? So web UI is a static web app that allows you to visualize and run the workflow in the browser. So this is how it looks like in your browser, by the way. And we also have an online gallery for you to try out as well. The entire web UI, although it's built on top of the JavaScript, we actually shipped inside inside the NuGet package as a third package, so you can easily install it in your project like the other C# libraries. And by shipping the StepWise web UI as a NuGet package, we actually be able to avoid introduce another platform dependency in the StepWise. So you don't need to install any additional software to run a host StepWise. Your application will be the only platform that for you to define, visualize, and execute the workflow. So before having the workflow presented in the web UI, there are a few extra things you need to set up. So you will need to set up the StepWise service, which will run as a RESTful API service in your application. And you can do that by using the use StepWise server API. And after you configure the service, you can then start the host and get the StepWise client, which will be used which will be used as a client class to add in the workflow to the StepWise service, and it can be then presented on the web UI. So this example shows how to add the prepared dinner workflow to the StepWise service. So you just get the StepWise client from the service collection. Then you create an instance for preparing dinner, and you add that workflow to the StepWise service by using the add workflow API. So that's all the things that you need to configure. So let's move to the prepared dinner workflow to see how it looks like. It's actually a workflow inside the online gallery. So we will just proceed to that website. Did I? Sorry. Okay. So here is how the StepWise web UI looks like in your browser. You can see that there's a left sidebar which will list all the workflows available in your application. Other than the prepared workflow, you can see that there are sequential if-else loop to show the different patterns that can be applied to show the example of the different patterns that might be helpful when you build a workflow. And in the middle of the screen, you can see that the entire workflow is presented as a React flow, as a graph. So the graph is built on top of the React flow, which is another open source library to build interactive graphic in the React framework. It's very useful and very powerful. Strongly recommend if you are also looking for building the solution of a graph-like solution or graph-like UI. And in the graph, every step is rendered as a card, as a node card here, where you can see the card name will be the step name, and we also present the description field in a markdown manner. And you can run the entire workflow using the control bar using Gino. I will show how to use the control bar to run it first. So on the top side of the screen is a control bar where you can run all the step or clear the result, auto layout. And you can also set the maximum parallel number to run when you invoke the workflow, and also the maximum step to stop before it proceeding. So let's run it entire workflow first. So you can see the indicator will show the status of the step, and will show a green mark after it's completed. So here under this configuration, all the result is being the self-dinner workflow is completed within 7 seconds, and we can actually go to the check history to see the running order. So we can see that those steps get queued first, and the start return the result first, because return the result first, and then the boil order, and cut vegetables, cook meat, cook vegetables, and finally serve dinner. So that's essentially one of the possible order to run this workflow. And once you complete running this workflow, you can also save the checkpoint, so you can get back to it later. So, and what if you change the maximum parallel run number to 1? That will actually introduce different execution order and probably cause a different running result. Because now we only have the one running thread, so we can imagine that some steps will not be able to run in parallel, and let's see how it looks like. So we can see now the step is running more like a step-by-step manner, and the dinner now takes 14 seconds to complete. And other than using the sidebar, using the control bar to run the workflow, we can also use Gino to run the workflow for us as well. So to use Gino, you need to configure the large language model first. So currently, we only support the OpenAI configuration right now, but the Cloudy and the Gemini support will be adding shortly after. Shortly after. And the Gino will understand the workflow. So because every step in that workflow will be mapped as a tool definition, so it can also invoke those steps to resolve the question. So for example, if we just ask Gino to serve me dinner, and let's increase the parallel number to 5. So when running workflow, Gino will also use a configuration in the control bar as well. So you can see now the serve bar gets getting invoked first. And once the step is completed, it will show a final message to summarize this workflow. Yeah, so that's StepWise UI. that's a quick example of StepWise UI. So let's go back to the slide. And if you, other than the StepWise UI approach to visualize and run workflow, you can also run the StepWise programmably using the StepWise Engine API directly. So there's an API called execution async, which is also used by the StepWise web UI to run the workflow step by step. So that's that API is actually the API that supports the entire web UI. So it has 100% of the functional comparing to the web UI. And yeah, so that's the end of the first section. So let's move on to the hands-on part, which we will build the weather chat workflow first, and then the train of thought workflow to improve the larger model response. So let me put it on the side of the screen. And get my favorite editor open. Oh, it's not CLI, by the way. Okay, so we will start by making a CLI, a .NET command line for .NET console app application first. So console main StepWise workshop. This will be where we put the weather chat and CLI samples. And let's cd into it and let it run to see if it's good. Okay, so now it's created successfully. So then let's add the StepWise package. So we will go to the NuGet and find out the StepWise package. And open the VS Code editor. Let me adjust the screen a little bit. Okay, so the first thing that we are going to do is we want to show the web UI in the browser first. So this can be done by let's go back to the previous slide to see how to set up the host. So this can be done by using the default host and add a StepWise server to it, and then start it start the host service. So host.create default builder, and I want to configure the web host as well, and we want it to be running in a separate URL. Web builder .use URL local. So we want to run the service at this port number, and then use set up a StepWise server as well. So the StepWise server will also take an optional configuration where you can configure the Let's see what it takes. Well, you can configure the workspace. So the workspace will be the folder where it saves the checkpoint and saves the images as well, and also set up the authentication. So currently, StepWise support you to enable authentication using Auth0 as a provider. That will be useful when you want to deploy your service, your StepWise service online and for the other developers to use. So, but currently I don't want to make any changes to the StepWise configuration, so we will just use the default configuration here. And after you have the host created, then you start it, and then you get the client from the host service collection. And then you can add the workflow here. And finally, we can just wait the host to be shut down. So that should be everything you need to have the StepWise web UI running. So let's run it quickly. Okay, what's the error? Okay, so the address is already in use. Okay, so I probably need to take a look at which service is still running on this service. I see. So let me close the other window which taking that port, and now it's can be run successful. So you can see the web UI is already running here. So, but the workflow is still empty. So we are going to add the workflow later, immediately after. And so the workflow that we built here is a weather chat. So it's kind of the Hello World example in the agentic workflow. So where you can get the current date and city, and use that to get a dummy result from the getWeather function. And here, let's just quickly build it. So in the StepWise, every workflow is modeled as a class, and every class is modeled as a method. So we'll first define a class called weather chat, which will put all the steps that we want to use for this workflow. And in this weather chat workflow, we'll go to define the get current date first, which will get the current date. So this is done by, so I will first add a step attribution here, and then define the get current date function, which will return the datetime, and returns the current datetime when it's getting invoked. And the second step we want to define here is the get city. So in the get city, we want to, other than run it from directly by the genome, we also want to allow user to provide the input for this step. So here we are using a special attribution called StepWise UI text input. So this will prompt a text input box on the StepWise web UI to accept input. As you can see, there are 4 special input steps that you can make usage: image, number, switch, or text. So here in this case, we're using the StepWise text input here. And we also set the description, get the city name, and yeah, that looks great. Oh, and in the StepWise, when you use the text input, the signature, there will be a requirement on the signature. So for the text input, the function signature needs to always return a nullable string, and and the values that you return here actually doesn't matter. So you can just return null here. And after you have those 2 steps defined, then you can go define the weather, get weather function. So in the get weather function, we just want to take the input from the get current date and get city name and return a dummy string for the weather to show the weather for that city. Get weather. So let's try typing it as a comment and see if the copilot can fill the rest of the code for us. Okay, it's a good start. So we still need to set up the dependencies for these steps because it seems that it's not correctly inferred by the copilot. And once after we set up the dependency, we also want to tell the StepWise engine to use the value of to use the result of a given step as the input for this parameter. So we also want to set up the front step, use the front step to do that as well. And that should do the work. Okay, so that's all the steps that we need to define for the weather chat workflow. And then let's add the workflow to the client. We can first create an instance of the weather chat class and use the add workflow create from instance weather chat. Okay, let's do a final look through. It looks good for me, so we will run the sample. And now the website started, and the workflow the weather chat workflow is available here. So let's run the workflow manually first. Okay, so we can see the get current date returns the daytime result, which shows the current daytime on my system. And the get city name, I'm just going to provide the city that I'm editing for now. And and we can see the get weather now return the dummy string that we want it to, as we expected. And let's also see how to use Gino to get weather info, to chat with us with weather information. So I'm going to ask Gino, what's the weather in Seattle and Beijing? Okay, so we can see that actually we can see that this time Gino can use the step from the use the get weather function from this workflow, and it invoke it twice, and finally summarize it and use that as final answer. So that's the weather chat part. That's a weather chat workflow, which is fairly straightforward. And in the next example that I'm going to show is a chain of thought. So chain of thought is a prompt technique that can be used to improve the lateral model response. So here I put the studio code for the chain of thought for this workflow here. So we can see that this workflow will start by taking the input from user, which will be used as task. So it will initialize the chain of thought for that given task and return the list of the subtasks to run. So here we will use a special contract class which we need to define in the workflow to host the name and the description for each of the subtasks. And after that, we will need to do a for each loop to go through every subtasks and use different model to generate answer for each of the tasks. And after the answer is retrieved, we will use that to update the subtasks and move to the next step. And this while loop will be continued until we reach the end of the subtasks. And then finally, we will use different model to generate the entire process and use that as a final answer. So let's put it back to the screen. So this workflow will be much complexer than the weather chat. So we will need to define the get input and the initial to define 4 steps or 5 steps, and also need to define a customized data contract to hold the intermediate result. So let's go back to the example. So before we do that, let's move the weather chat to actually a separate file to get some cleanup. Having the namespace get set up, and remove the weather chat here. And we're also going to add cot.cs, which will be the class to host the chain of thought workflow. And in this workflow, we will need to use the large language model. So here we will use the OpenAI to generate the answer for the initialized chain of thought and for the sunrise. So we're also going to add the package, the OpenAI NuGet package as well. So let's go to the NuGet gallery and search for OpenAI NuGet package and install it. Okay, so now let's install it. So here let's start with the first step, the get input. So we will still use the get StepWise text input here, and so which provide a chance for the user to provide the task for the workflow. Get the task from user. That will be the description we want to put to that function. And it looks like this time the copilot is doing its job. And after that, we want to move towards the step of initialize chain of thought. So initialize chain of thought will take the input, the string input from the get input step, get task step, and return the subtasks. So here we need to define the contract for the subtasks first. So I actually already have it defined somewhere. So I will just go paste and copy and paste it. So you can see the contract class is essentially just like an ordinary class. It's ordinary class that hold unnecessary information. It actually doesn't need to be a record class. It can be an ordinary class. And here we mark some JSON property name to indicate how it's been serialized and described to JSON. And in this class, we also override the toString method. So that's actually how that will actually how the web UI be how this class will be displayed on the web UI. So you can imagine that when you visit the result for this subtask on web UI, it will actually be the value of the toString method. And in the subtask, we have a task and intermediate result. And we also, other than that, we also create. We also want to have subtasks created. So why don't we just use the list of the subtask as the result of the initialized chain of thought? This is because we also want to see the complete result of all the tasks instead of the default toString method for the list of the subtasks on the web UI. So in order to do that, we define the wrapper class, the wrapper subtask class, and override this toString method. So all the subtask information can be properly showed on the UI. So after we define the subtask type, we can then move towards the initialized chain of thought. So let's start by step and put the description, initialize chain of thoughts for a given task. And it will depend on the get task in the first step. And for the signature of this function, we want it to, it's actually already generated by the Copilot. Oh, and by the way, the Copilot is not free to use, just for your information. And in the initialize chain of thought, it takes the input of the user task and return a list of subtasks. So inside this function, we will want to use the larger model to generate the list of the subtasks for us. So we start by define the prompt for it. So let me copy and paste the prompt from somewhere. So inside of this prompt, we can see that we just put the user task here and ask the larger model to generate a chain of action. And we also, inside this prompt, we also define the scheme of this subtask. So we ask the larger model to generate a valid JSON array that we will need to parse later. And after that, we will need to use the chat client to send this prompt to the OpenAI and generate response. So because we have multiple steps that will need to access the larger model, so here we can just put the chat client as a private field. So we only need to initialize it for once. So I'm going to create a read-only field for the chat client. Chat client. And I'm going to initialize it in the constructor. So I already have the OpenAI key somewhere on my system. So I'll just grab and use. And after we have the OpenAI key, we will create the OpenAI client. And get chat client from the OpenAI client. So here we will use the GPT-4 as a larger model. And here we will send, after have the chat client, we will then send the prompt to the larger model and get response. So we can do that by define the system message, system chat message, yes, chat message, and use that to get response. Complete chat async. And after we get the response, we need to do to tell if it's a text response or not. Although we don't pass any function definition, so it should always be a text to be a text response. But we still want to check it here. Equals 1 and response.value.content 0.text is text, is string text. So here we will parse the result as subtasks. And if it's not, then we just throw an exception. So subtasks and so because in the prompt we are asking the OpenAI to return a list of the subtasks. So we are parsing it as the subtask array, and we will use that to return the subtasks when return the result. So that's everything for the initialized training of sort. We can quickly validate it in the UI by running it. Oh, I still need to add this to the program.cs. Okay, so now the train of thought is available here. So I'm going to test the classic task about a number comparison. Which number is larger, 9.9 or 9.11? And the result is being, and you can see the task has been separated into a list of subtasks, and the toString result of that class will be returned here. So that looks good for now. And after the initialized train of thought, we are going to implement the rest of the workflow. So we will go, the next will be the resolving subtasks. So it will take the subtasks as input and also the I, and it will resolve that subtasks and use that to update the result. So let's do that. And next to the initialized train of thought, let's add another step called resolve subtasks. And in the description, we're going to put the description to be resolve the I's tasks from the task list and return the result. And return the result. And we want this step to be depends on the initialized train of thought. And the name of it is resolve subtask. Okay, now it's just, now the compiler is just trying to be too smart and start making the API that doesn't exist. And along with the subtasks, we also want to implement the index equals to index plus 1. So we're also going to put it in another steps called move next or call the next, which will update the index, which will take the input of the current index and return the index plus 1. Step description, move to the next subtask. And inside this function, we want it to return integer and the name to be next async. And it takes the result from the previous result, from the most recent result of the resolve subtasks. And we also want to, in the resolve subtasks, other than returning the answer for that subtasks, we will also include the current index in that result as well, so that next async can make use of that. And by the way, the type must be matched for the from task attribution. So here we can see the type actually strictly matched here. And in the next async, we just return the result item 1 plus 1 to indicate, to invoke the resolve subtask to run the next step. And in this, we will, in setting up the index, we will use the result of the next async here. And here we want to set up an initialized value so that it can be invoked when the next async is not invoked. So you can do that by setting up the default value to 0. That will be mapped into the index to 0 in the Studio code. And in the resolve subtasks, what we want to do here is that we want to send the intermediate result to a larger model and ask it to generate the answer for that subtask. So we are going to use the string builder to include all the tasks that has been completed, and use that to as a prompt to send to the larger model. Response, and want to check the text if it's a text message, and if it's not, then throw the exception. And here we also want to save the intermediate result, so I'm going to add another field here called subtasks, and we're going to update it in the initialized train of thought. And also update the corresponding result when the resolve subtask get invoked. Yeah. So after the updates the intermediate result, we also will return the index plus the answer to that task as the result for this subtasks. And so the execution will be when the user get a task first, the initialized train of thought will be invoked, and then the resolve subtask will be invoked next, and with the default index to 0, and the subtasks as a result from the initialized train of thought, and then the next async will be invoked, and the next async's result will return the index of the next subtask to complete, and it will invoke the resolve subtasks until, now we missed until the exit loop. So here we're making the result to be a nullable, and we simply return a null to indicate that no more execution because the index is larger than the existing task lists. When the index is reaching the end of the subtasks, the resolve subtask will be written null, indicate that it's been completed. And finally, we want to invoke the summarize step as well, to summarize the entire process. Complete the chain of thought. Let's replace a complete with summarize. And it depends on move next. And the input will be the from step. We want to use the index to be the input for this class, so that we can know that if the if the result has been, if the entire chain of thought result has been completed or not. And here, if I is greater than the length of the tasks, if I is greater than greater or equal than the task, we know that the task has been completed. Otherwise, we just return the result to indicate that the further step is going to be run. And in this step, we will get all the results for all the subtasks and use that to send to the larger model for summarize. So we are going to use another string build here and append all the tasks and its result to the string builded and use the prompt and create a prompt for summarization. So here let's just copy, just put the prompt to be summarize the chain of thought, and then along with the result. And we want to send that to the larger model as well. So enter, tab. Okay, so it looks like it's now do another check to see if the response is text, and if it is, then return text. Otherwise, throw exception. So that's a summarization step. And at this stage, we complete all the steps for this workflow. So now it's time to run it, run and verify it. So here, let's still try with the classic ask, which number will be larger, the 9.11 or 9.9? And we can see the workflow start running, and the result subtask get invoked, and we can see the iteration is now iterate over the next and the resolve steps. And because the max step is stopped at 10, so it seems that the result is still not completed after 10 steps. So we can just continue running by clicking on this step. Okay, so now I equals 5, and that will be the marking the complete of this entire step, entire chain of thought, and let's examine the result. Okay, there are just so many tasks. So many tags. So let's just ask Gino to summarize the flow. So it seems that it's comparing the 9.11 and 9.9, but it's also comparing this hallucinated number as well. So, but anyway, it's returned the partially correct result. And we can also have Gino to run the workflow files as well. So if we just provide the task for to Gino and see if it can use of the workflow to complete the answer. So I'm going to ask the Gino directly about the question, 9.9 or 9.11 using COT.
That's pretty cool. I mean, you put there a raw agentic workflow just by using the workflow engine. So I really like it. Will you post, or maybe it's already the COT example in the gallery?
Sorry, can you say the question again?
Yes, if you will put this example, this chain of thought, I think it's pretty cool example, right? A site that it says that 9.9 is greater than 9.11, but I think that's a matter of improving the prompt. But will you post this example in the gallery?
It will be, so yes, it will be in the gallery, but it will be in another agentic gallery. So I'm
Ooh.
currently working on that. There's an issue
Hmm.
agentic stepwise gallery, and you can see it's on the list.
Nice. That's really, really cool. Uh, Going to the group chat, if I may add another question, I was thinking what you did at the moment is on one step, you created a full-fledged everything you need to run a model or to do a query using the chat with a model. But I mean, you can do that kind of under context and create a chat loop in the workflow class. So you can keep the history in the context and iterate and every step go through that. I guess that is what would work, right? Or maybe you have that implemented.
Yes, that should work.
Really cool, really cool. And next question, I'm thinking ahead a bit. If we go full agentic here, and I love agents, and you do as well. How about having the tools maps as a task, as a step here? So what I really like is that you can visualize everything which is happening in the workflow here, absolutely everything, and you have full control. It can also ask a question to you. It's kind of a chat interface, but based in a workflow. It's pretty cool. But if we put a agent that can use different tools, is there a possibility that we get to see somehow what is going on in the UI? That would be really fantastic.
Um, I actually don't quite follow the question. Can you repeat?
Yes, uh, an agent or an LLM can use a tool, right? Can use function calling.
Yes.
If you attach a tool or a function, that could be a step or be considered a step on the workflow that needs to be executed. Then the value returned to the agent or to the LLM that invoke that, right? It would be nice to be able to see that from stepwise visually.
Oh, it's actually already available.
Oh, wow. You
Yes.
make my day.
Yeah. So actually, so it's still experimental, but but you can see that in the but there's experimental tryout to leverage the stepwise workflow
Hmm.
in the AutoGen agent using the function call definition, using the function call middleware. So here
Hmm.
is the example of how to do that. So
Yes.
you can see the workflow is still we use the get weather workflow here, and it's the same weather chat workflow, very similar weather chat workflow here. And here we have a special middleware called the StepWise middleware, which will extract all the function call definition from a past workflow and use that and pass that to the agent. So we can actually try running it.
Oh, wow.
Yeah.
Thanks.
But there are still limitation to that. The limitation is one of the limitation is that there's a limitation on what kind of the input parameters you can put in the step call. So it has to be within it has to be a legitimate primitive JSON type, string, integer, string array. That's the primitive that I'm talking about. And for the steps that take into the other input parameters like a custom defined contract class, that's still not supported yet. So, but as you can see here, the weather chat agent can invoke is now able to invoke a stepwise workflow and use that to get the result. So here
Hmm.
the assistant actually gets the use the get current data async step from the workflow, and then use that to get the weather async, and use that to generate the final response.
Nice. Very nice. Thank you.
Thanks. Okay, so yeah, so let's go back to the. Actually, it's also marking the reach to the end of the session of the section 2 session. Hopes that you still the audience is still satisfied with the demo, and like yeah, thanks for the joining the session. And now let's move to the Q&A if there are any questions. Oh, and for the final call round, so this is the GitHub repository for the StepWise, and please give us a star if that makes you feel if you like it. And there's also a gallery for you to try out on the website. And we're also working on Agentic library that will be available shortly after. And thanks for watching.
Cool. Really cool. So we are watching the stream. If anybody wants to make any questions, I will read them to Choyun. Meanwhile, I have another one, which is that was cool to see a middleware already implemented for doing that. Do you plan to integrate that with other agentic frameworks as well?
That's on the roadmap.
Oh, that would be fantastic. Because then there's one more question. You know that our friends at Semantic Kernel at Microsoft are also implementing something called the process framework, which has a very different approach to what you're doing, which I find it really, really interesting. So I kind of really like your syntax, which is based on decorators, than the other one, which is based on fluent syntax. So it's do you plan to try to match these two together so you can parse as well a process from the process framework?
Actually, so I feel like there are both different and common places share between the stepwise between process and stepwise. So and process is also event driven, and I feel like the major difference is that the process will have a starting point, but all the other implementation looks very alike to each other. So I feel like it might be possible to map in the process frame a process workflow to a stepwise workflow and use that and run it in the stepwise web UI. Theoretically, I feel that's successful, but I will spend some. But it might need some further investigation to see if it can go through, and I will definitely give it a try on this meeting.
Well, that's fantastic. We are waiting for some questions there, but there's not too much around. So I will take another one. Where do you take the energy to work on all these projects? Because your GitHub is really, really, really impressive. If you go to uh, the one that I show a bit before GitHub, let me show it. Little Cloud, you can see that his Sherion is really, really prolific, and also you are having like I don't know, but a full journey pro coding programming. So you're aside from work also doing a lot of incredible things. How do you manage that? Where do you take the energy?
Well, the GitHub history is active because it also includes the commits that I make for work. So actually, I guess why one of the reasons is that my working on the open source project and working like the AutoGen and all the machine learning and the semantic kernel is also part of the work that I'm assigned to.
Well,
Yeah. So other than that, I'm also really enjoy creating and contributing to the open source project at StepWise as well. So it's something that I love doing. I love to do. So I actually don't feel like it's cost a lot of my energy. I guess what I want to say is that I enjoy doing this when coding and working on the open source project, resolving user tasks. And even better is that for some of the tasks and for some of the code, I even get paid from Microsoft.
Cool. That's really cool. I'm happy to hear that. Choyun, I see there are no questions, so thank you so much for being here. And again, I request the audience, if you like what you see, go to the GitHub repo, which is shown on the screen, and give him a star, at least. He deserves that. Thank you, Xiaoyun.
Thanks.
As they say, my Chinese is not good, but 谢谢.
Thanks.
And everybody, have a great evening and happy holidays.
Happy holiday.